This is the first major part of the Making Sense of Statistics in HCI series. I'm going to talk about, it's called Wild and Wide. Don't know if you think about statistics as being wild, but anyway, we'll get as wild as it gets. And what we'll do is look at the nature of randomness and trying to give you a gut feeling for randomness. So you might have this idea of randomness, so there's the word randomness, but just to sort of tune your tummy to what randomness actually is about. As part of this, we're going to do some talking about stuff, but also you're going to do some experiments yourself. So get ready to do something active. Okay, this is it. This is when you actually do stuff. So we're going to go through a couple of exercises that are about trying to give you that sense of what randomness means. First of all, I've got a story. So don't try to read the slide on screen, so I'll tell you the story. So it's the far-off land of Geishra. It lies on the plain of Nali. So the plain of Nali lies flat and huge for hundreds of miles in all directions. And in the middle of the plain is this pavement. And it consists of 25 tiles, square tiles of stone laid out in a 5x5 pavement. And it's perfectly level with the ground around. The rain rarely falls on the plain. It's dry and but not too dusty, so but dry and flat. But every so often a cloud gathers, and as it comes over, rain falls. And when that happens, the monks of Geishra set off and they walk out towards the pavement in the middle to watch the way the rain falls. And sometimes the rain just falls as rain, but sometimes in the patterns there is a message and an omen. So what I'm going to do is show you 3 days. They go there once and it rains for 3 days. And I want you to look at those 3 patterns of rainfall and decide whether you think each one's going to be randomly, the way the rain would just fall, or an omen. So here's the first day. So have a just peek at this. You can see them all side by side in a minute, but just look at that and just get a feel. Do you think that one's random? Do you think it's an omen? Okay, that's day 1. Here's day 2. Go back day 2. Again, look at that. Random, omen. And finally day 3. Again, look at it. Random or omen. So here they are, all beside each other. And I want you to think about them, look at them, decide for yourself which of those. And I'm going to give you a clue, in fact. Only one of them is actually the way the rain fell. The other 2 are omen days. So it makes life a little easier. So you've got to choose one day as the day you think is the random rainfall pattern on those tiles. So have a look at them, think about them. So I want you to look at them, but also I want you to say why. So, and you don't have to write it down, but you could write it down for yourself. So make sure you don't cheat when I tell you, and write down for yourself what you really think is. Nail your colours to the mast, but also try and think why it is that you've made the decision you want. So there you are. Look at them for a while, and while you're doing that, I'll take a cup of tea and think about things. Okay. You can pause the video if you like at this point if it's being too quick for you. Have you had a thought? Which is going to be? So first of all, I'm going to tell you something, which is what happens if you do this with small children. So if you do small children, very small children, like 3-year-olds, it's all over the place. They're pretty much even. But if anything, they tend to bias a bit towards day 1. However, by the time they get a bit older, so say about a 7-year-old children who learnt a bit in schools, they know a bit more than the 3-year-olds. Again, there's quite a lot of variation, but they're slightly more likely to choose day 3. So I don't know whether you're a day 1er like the 3-year-old, a day 3er like the 7-year-old, or maybe you've gone for day 2, which is like neither of them. Maybe like a 70-year-old. So which to do? Just keep track of them. We'll just go through these and actually talk about which is which. And I said you might have looked at day 1, for instance, and seen like there's almost like a diagonal line along the middle. Is that an omen? Different things go on. So let's look at day 1. So day 1, I said, you might have thought, the standard line. In fact, if you look at the second square along from the top, there's a dead straight line there. So you might think, whoa, that can't be random. In fact, as near as the random number generator on my computer can manage, this is an entirely random pattern. You might have also thought that there's some entirely empty squares, and that couldn't happen if it's random. That looks like it's a setup job. In fact, it's not the case. It is likely there'll be empty ones as well as full ones. And very often when you have random things, your eyes are brilliant at seeing patterns. So what happens? You see stuff and you think there's something there. And actually, just like that sort of diagonalish pattern there, purely random, just happened to be that way. Okay, day 2. I've noted this was the 3-year-olds. The 3-year-olds got it right. Day 2. In fact, it's exactly the squares. You might have noticed this. It's exactly the same patterns from the previous one, but the squares have been reshuffled. And you probably realise that this is a little empty towards the outside, a little clustered to the middle. And that's exactly how this was constructed. It took the random squares and then reordered them so that the fuller ones are in the middle and the emptier ones on the outside. So that really isn't random. That is an omen. Something was going on towards the middle. It was pointing you towards the middle. And then finally, day 3, which is what the 7-year-olds plump for, and actually a lot of adults go for, as thinking this is the random one. But it isn't. In here, in fact, there's exactly 5 raindrops in each square. And that just doesn't happen, really. You get a distribution. It's too good to be true, basically. But weirdly, I said it is what most 7-year-olds go for. They've learned through schooling that random actually means uniform, and it doesn't. Random things often have quite a lot of spread to them. So we're going to do another experiment now, which picks up some of these themes. And I call these 2-horse races, right? So what I'm going to do is you probably need to pause me here and go off and get some coins. And ideally 20 coins, but if you've got less, you can, because if you've got lots of coins, you can line them up and it's nice. If not, you can just write down numbers on a piece of paper and keep tally. But if you can get lots of coins, and what you're going to do is take a coin, and I'm just dropping mine all over the place. So take a coin, toss it again, it's not very good up, look at it, and this one's come out a tail. And I'm having to put them into this little cardy thing, but you just put them on a piece of paper or put them on the table. And I'm going to have the bottom line is going to be my tails line. So that's a tail. I toss another one over there, and it's come out another tail. Going to toss another one, and this one's come up a head. So because it's a head, I'm putting it in the top. Oh, I'm not showing you these very well. So there's the 2 tails, and there's the head one. I said you can just put them on. And what I'm going to do is go and keep on tossing until one of them gets to 10. And I'm going to say that one's 1. So this is like the horse. This is my 2 horses. I'm going to have a head's horse and a tail's horse, and they're racing away, and we see which gets to 10 first. So I want you to do this, but before you do that, just think, what do you think is going to happen? What do you think the pattern will be like when you get to the end? What do you think the pattern as you play it will be like? So if I've got a big room full of people, I get everybody to do it once. What you might like to do is do this several times, because then you'll see different things happening, I guess, and it'll be interesting. With a sort of room full, you get different things to people. But I'll tell you a bit about some of the things that occur to people. So if you go off and do that, I'll fill out mine, and I'll have a cup of tea, and you can pause me and see how we're getting on. So come back in a few moments, and. Okay, have you finished? Have you got a few there? If not, I said pause me and you can go on. So I've finished mine. So I don't know what you thought would happen, but here's how mine came out. And I got 2 tails and 10 heads. Now actually I'm fibbing. I cheated a little on this when I set it up. But this is this. If I have a room of 50 people, I would very often have something like that. In fact, we'll come back to this in a moment, but you might have thought, and again, having done the little exercise about the planes of Gaisler, you might have started to think again about this, but my guess is you would expect this to come out pretty much even, that there'd be a head-and-head race and one of them would nip in at the end. It's quite likely you had something that was very different from that. This is quite extreme. The likelihood, I'm just going to pop them out, the likelihood of one of them winning without the other ever getting any is only about 1 in 500, about 1 in 1,000 for each. So that's quite unlikely. However, even getting one, having a 1 to 10 win, there's about 1 in 50 chance of that. So if I've got a room of 50 or 60 people, it's quite likely I'll see that. It's incredibly likely I'll see at least one person getting a 2 to 10. I was at a conference recently, at the Chi conference, and we got 2 10 to 1 wins in that room of about 60 or 70 people, which is reasonable. So actually, this comes out typically a lot less uniform than you'd expect. So I've got my picture there. Forgot about my picture. Okay, so the world's actually really random. The probability of an individual head is 50-50. But that doesn't mean that if you toss coins, you'll get exactly half of them being a head, half of them being tails. Typically, there's a lot of variation. Now, if you keep on doing it, so if you've played this game multiple times, you might well get sometimes the heads winning by quite a bit, sometimes the tails winning by quite a bit. Sometimes there'll be evens, but often you'll get things that are more like this. But on average, you should get as many of these with the heads right to the end as ones with the tails right to the end, but over a lot and lots of tosses. I'll show you some software you can play with this sort of thing a little bit more, because it gets boring after a while tossing lots of coins. But just toss coins and you'll just see that the world is quite weird. So just some lessons from these 2 exercises. First is apparent differences you see, things that look like they're patterns, like in the planes of Gaisler, you thought that looked like there was a diagonal line, can sometimes be there purely through chance. The nice thing about doing things like tossing coins is there isn't a systematic effect. There's nothing real under there. It is just random. And so when you see those patterns, that actually they were there from the random chance. When you've got your real data, it's actually quite hard, because you don't know what's the real effect and what's the random thing. The other is real data can in some sense have bad values, things that look weird, things that actually aren't. So you tossed your coins and it came out 2 to 10. That doesn't mean this is a biased coin. It just means it just happened to come out that way. Interestingly enough, there's a number of historical experiments where you can see people had results like this and thought, I must have done something wrong. So Mendel, with his with genetics and sweet peas, if you look at his results, they're a little bit too close to like 50-50 when you mix 2 parents and you see the mix, or some should be 3 to 1s. They're too close to those numbers. In Millikan's Can experiment, which is where they measured the electron charge, again, the results are a little bit too good, a little bit too close to a discrete value. He was expecting to see discrete values of charge, and they were just a little bit too close. And the guess is that what happened with both of those is when they saw values that were not what they were expecting, they thought, I must have done something wrong. When actually, in fact, just like with coin tossing here, the likelihood is that it was just pure chance that you sometimes get weird results. So do expect weird results. You will get them. That's normal. But also beware of making too many inferences just on what you first look at. So if you looked at that, you might think, biased coin. And you often have to have a lot more data before you can make an inference like that.